Today, we're diving into a math puzzle you can actually hold. A whole story told in just 8 fascinating pieces. Okay, so take a look at these. We've got 8 colorful, kind of weird-looking blocks. At first glance, they just look like a random jumble of shapes, right? But there's an elegant mathematical secret hidden inside. And our job, together, is to figure it out. So where do you even start with something like this? I think the best first step is to see if we can make some more familiar shapes out of this jumble. Let's go on a hunt for cubes. You know, with all these complex shapes, there's one piece that just stands out. It's way simpler than the rest. I bet your eyes went right to it. Yep, it's that solid yellow block. And there it is. This yellow piece is a perfect little cube. It's 3 units long, 3 units wide, and 3 units high. You can actually see the little blocks it's made of. You could count them if you wanted to. It's 3 layers of 9. So we'll call this our 3 cube. So what's the volume here? Well, 3 times 3 times 3, that gives us 27. And that's the key thing, right? This cube is made of 27 smaller individual unit cubes. So hang on to that number, 27.
Okay, 1 cube down. That was the easy one. Let's get a little more ambitious now. Can we find a 4 cube hidden somewhere in this collection?
So if you look, you'll see there isn't a single piece that's already a 4 cube. But look at that big green block. It's so close, isn't it? It just has this little notch taken out of it. And what about that small gray piece? The one with just 2 units. Well, guess what? It fits perfectly right into that empty space. And just like that, together they form a perfect 4 by 4 by 4 cube. So what's its volume? Let's see, 4 times 4 times 4 is 64. Bam! We have our 4 cube, and it's made of 64 little unit cubes. Okay, so we found a 3 cube. We built a 4 cube. I think you can guess what's coming next, right? We're going to build a 5 cube, and this is where it gets really interesting. A bit of a challenge, for sure. Okay, to make this 5 cube happen, we need all 5 of the pieces we have left. Yeah, all of them. The purple one, the red, the pink, the white, and the black. Seriously, they look like some kind of crazy 3-dimensional jigsaw puzzle. But with a little bit of thinking, a little spatial reasoning, they snap together perfectly. It's amazing, really. It just shows you how these really complex shapes can combine to create something so simple and perfect, a 5 by 5 by 5 cube. And the volume? You got it. 5 times 5 times 5, that's 125. So just to recap, we've now used all 8 of our original pieces, and we've made 3 separate cubes. Okay, let's just pause for a second. We've got a 3 cube, a 4 cube, and a 5 cube. Now, if you're into math at all, that number sequence, 3, 4, 5, that's got to be ringing a bell. It sounds just like a Pythagorean triple, right? You know, for a right-angled triangle. In 2D, 3 squared plus 4 squared equals 5 squared. It's famous. But the question is, does that same logic hold up here, in 3 dimensions, with our cubes? Let's actually check the math. So in 2D, with squares, you have 3 squared, which is 9, plus 4 squared, which is 16. Add them up, you get 25, which is exactly 5 squared. Perfect. It works. But now let's try it in 3D with our cubes. 3 cubed is 27, 4 cubed is 64. Okay, add those two together and you get 91. That is definitely not 125, which is the volume of our 5 cube. So what's going on here? It seems like that famous 3, 4, 5 rule just falls apart when we're talking about volume. And this is where the real magic of this puzzle happens. See, we took all the pieces apart to build 3 smaller cubes. But that was never the real point. The ultimate goal wasn't to keep them separate. So let's put them all back together. So here they are, all 8 of our original pieces. We know we can sort them out to make a 3 cube, a 4 cube, and a 5 cube. But what happens if we try to put all of them together into one single unified shape? They form this, a single perfect 6 by 6 by 6 cube. Can you believe it? Every single one of those 8 weird, complicated pieces has an exact spot in this final, beautiful structure. It's just a masterpiece of design. And the volume of this big 6 cube, well, 6 times 6 times 6. That gets you to 216. That's a grand total of 216 unit cubes, all fitting together flawlessly.
Okay, we have all the numbers now. Let's connect the dots and finally reveal the beautiful hidden equation that this whole puzzle was built to show us.
All right, let's just run through the volumes one more time. The 3 cube was 27 units, the 4 cube was 64 units, and the 5 cube was 125. Now, what happens if you add the volumes of those 3 smaller cubes together? So, 27 plus 64 plus 125, it equals 216. And that, of course, is the exact volume of that big 6 cube we just built. And that is the secret. That's the mathematical idea that this whole puzzle exists to represent. 3 cubed plus 4 cubed plus 5 cubed equals 6 cubed. It's just a stunning, beautiful truth that you can actually see and hold. You know, this kind of puzzle actually has a name. It's called a cube dissection. And it's basically a physical model designed to take an abstract idea from algebra and turn it into something you can see, touch, and just get. It's really math you can feel. And that's what's so cool about this. It shows you the power of using physical things to understand math. It really makes you wonder, doesn't it? What other amazing equations and beautiful mathematical truths are just out there, waiting for someone to figure out how to build them?